All right, I want to go back to keeping this archive after a short break. I have worked on pathfinding more, and I pretty much got rid of all of the bugs, at least surface level ones. And I ended up implementing something along the lines of this. So it does proper movement and stuff like that. I had a little bit of a kind of memory usage problem there with how I was returning my results, but that's all fixed now. So we got movement in a level, which is pretty nice. There are still a few quirks, a few things I would like to do differently, and stuff like that. And yeah, as you can see, now I'm spawning in a room properly, not just in a fixed position, but actually in the center of the first room. So yeah, today I just want to do a quick update on that, right? And just to kind of take a look here, I did want to mention a little consideration. Oh yeah, but before I do, I did change this algorithm to basically work in indices rather than in those integer vectors, except when we want to actually, either access the map or kind of, move in a position that's like logical to the map and stuff like that. And also one other thing is that I ended up only keeping so like if we look at recalculate path, we're only keeping the first target. Where is that? Yeah, we're only keeping the next target that we're moving to. That's what we're caching. And then when we arrive at the target, we recalculate the whole path and then move to the next target. So that prevents that like flip-flopping as we're moving once we have set the target. But we are still updating our path and stuff like that. And another thing that we could do is if a path, like we can, every time we are moving, how did I just do? Every time we're moving, guess I don't need that anymore. Every time we're moving, process character orders, I could just first check this for obstruction, right? So if there's line of sight, then we can continue moving. If there isn't line of sight, then we should just recalculate the whole path. That's what I want to do eventually. Yeah, so that's pretty much it for that part. And today I just want to kind of get back into the groove of things. So it's not really gonna be a serious session or anything like that. But if I look at my to-do, which I already thought of more and realized there's a lot more kind of intermediary items here that I'm missing before stuff like, overworld and all that. But yeah, you can see here, this is my high-level plan. And what I'm actually planning to do next is this. I want to work a little bit on line of sight. And the way I'm envisioning this is that it will be a sort of continuous line of sight in this kind of tile-based world. So I want to be able to be blocked by a tile fully, right? My field of vision. I don't know how to demonstrate it best, but basically if you imagine this, Like I want to be able to see this room, right? But then like as it goes outside of the room, I don't just want to do this like roguelike kind of lighting or, you know, line of sight that is already embedded, or not embedded, but like discretized into the tiles. I just want to have a continuous line of sight. And I will be always comparing line of sight between entities and stuff like that by that continuous line of sight. So it's going to be independent of the actual tile coordinates. And then if we want to see if a specific tile is in view, we can just sample kind of the middle of that tile basically and see if that is in that shape or not. And before I do that though, or maybe not before, maybe kind of during, or maybe even I'll leave it for later, but I just want to think a little bit about my rendering. My rendering API, because I'm missing quite a lot of stuff in my rendering that doesn't allow me to do a lot of things. I mean, you already see my line drawing algorithm, that's actually a triangle, right? And obviously it doesn't work that well. If I, you know, zoom out, you see these kind of gaps and stuff, because it's not actually trying to draw a pixel line, it's trying to draw a triangle and stuff, so it's different. And I think like it's not that I can't do it with lines, but there are a couple of things, like as in the kind of draw call in OpenGL being how do you say it, requested in the lines mode, right? I could do it, it's just it doesn't really fit. I don't have a well defined API for that, and ultimately I just don't like how I do my vertex batching. So I would like to spend a little bit of time now to kind of just prototype a little like what I would like for that API to look like. Okay, so the way it is right now, I'm gonna try not to go too deeply into this, so I don't spend all the time explaining how it works. But the way this is right now is that we have these vertex batches, which is basically referring us to the VBO, meaning the vertex buffer, the vertex array, the element buffer. I think that's the GL names, right? All this stuff basically to kind of be able to do one draw call. That's the idea, right? Is that we just assemble a batch, and whenever we're ready with the batch, we just issue one draw call instead of doing a draw call on every kind of primitive, right? So that's how like I can draw that tile map as, you know, separate quads, but the actual data, it does the whole tile map in one draw call basically, instead of how it before, and like that immediately ruins your FPS, right? Even that's enough. Even this small amount of data and drawing is enough to kind of bottleneck. So obviously that's no good. So I wanted to batch it. So I have this thing, right? And then I wanted to actually be able to use it kind of for different vertex attributes, right? So if you have some special shader that needs a bunch more data for each vertex, or for each draw call, or sorry, for each like, I guess, primitive or whatever, right? We want to be able to kind of specify that. And this is the little kind of thing I came up with to have this vertex batch specification. That basically has this array of attributes. Each attribute we see, like, is it enable, is it integer? I don't know, I don't really want to like go into detail, but basically we have this for each attribute, and this allows us to know like where to sub the data eventually, and stuff like that. And basically if I look at, I guess just in here, I think I have like initialize, no, well, okay, I have this code here. Okay, init GL defaults, yep, which is right here, and this is where I actually specify the default vertex batch, right? So that's kind of what that API looks like. It's pretty much just this. So it's kind of, I don't know, it's not terrible, I think. Maybe it is, but it's not like let's put it that way. Let's put it this way. It was a lot worse. So it's better now, and I'm able to kind of specify all that. And I did this thing where I kind of, the idea was to specify an enum for your attributes for each of these vertex buffers, or vertex batches, so that later you don't just have to like keep the right order, or you don't have to refer to them by index. You can just have that name that is always referring to the right attribute, so you don't make mistakes there. So that's kind of the definition. I just say begin vertex batch spec that creates the batch. Then we specify each of them with like number of components, the size, and yeah. And then we end the specification. And yeah, we also have this prepare vertex batch, which actually like how do you call it? Actually like initiates all of that state on the GPU. I guess it's pretty simple. I thought there was a lot more here. But yeah, like I do this also where no, not this. Basically, somewhere I like store all the offsets for each attribute right away, so I don't have to recalculate and stuff like that. So basically, okay, I think it's kind of clear enough. What I want to replace is this whole thing. So the way it works right now is that when you call these kind of sub calls, it immediately goes and takes whatever data you have here. I guess this little function just like tries to have some like sanity in terms of the type of data, at least in terms of the size. So it's like you pass it in, but it's pretty much just used like all of this data just to assert that, you know, the caller kind of knows itself, or, you know, it basically adheres to what the vertex batch is expecting for that kind of attribute, right? Just little sanity checks. But yeah, so I think that that's fine. So like it doesn't, so it's up to the user to actually do the memory management on the CPU side. But then it results in this kind of nastiness, right? So for example here, okay, line is easy. Well, it's actually just a triangle, right? But so it's like we can do this, all this on the stack, that's fine. But like when I'm doing, for example, I mean even this, but like let's say the tile map stuff, right? I have to actually allocate this on the arena, and I have to like calculate it in this way and like save it to this array, and then only I can sub that data in. So what I would like to try to do is try to avoid a bunch of this boilerplate and stuff, and also kind of simplify how I manage my memory, like as far as the user is concerned. I mean, it is good obviously to give user control of that, which in this case is just to me as well. But this is like, I'm kind of seeking some convenience here, you know, and then later I guess I can also expand it back again to something where that's more flexible. But I mean, ultimately I'm just experimenting. Ultimately I'm just trying different things out, and I think it doesn't hurt to actually try these different approaches to the APIs and see what, you know, is the most convenient and at the same time the most extensible and stuff like that. So I've done a lot of talking and I pretty much went over the mark that I wanted to go over, but maybe I can just do something very quickly in like the next, yeah, let's say 3 minutes, up to 20-minute mark. I just want to take this function and I just want to paste it into this if zeroed out chunk, right? And I just want to imagine what this API would look like. And what I'm thinking is sort of something a little like old GL inspired, but with the ability for that, like, you know how there's like GL vertex or whatever, for that to be able to be for any attribute that you want, right? So there will be some nastiness there in terms of like void pointers and, you know, losing the type data and stuff that I'll have to think about. But I think it should be doable. But like the basic idea is to avoid all of this. And let's say like right now it does two batches, first the backgrounds, then the actual glyphs. So let's say we're only dealing with the glyphs, or yeah, no, only glyphs. And that means I won't need this color background stuff. And in general, actually, I will not need any of this arena stuff. Maybe I can keep that for a quick second. But, so like, okay, let's say I still have the draw call the same way. No need for this. The basic idea is that once we have calculated all this shit, right, like for example, here we're doing points, which sends it off to the positions. And I want to be able to just call a function that's going to be like vertex batch I don't know, vertex batch vert begin or something, and like vertex batch vert end in the end, and probably it would be in here. And then here we do like vertex batch vert attrib, and we want to basically pass what type of attribute it is, which I guess I shouldn't have gotten rid of everything. So stuff like this. So like for example here I want to pass something for that attribute, and it will copy, like block copy whatever I pass in here into its own memory, which it might be just backed by an arena. of some sorts, and maybe it gets cleared out every time we do a draw call. Yeah, so like for example here, this is the point. And if I look at that 4v3, well, I don't have to look at it, it's just 4v3. So it'll be a v3, right? So I want to actually pass a pointer to that data because the function doesn't know how big it is. And I mean, ultimately, right? Ultimately, that's the most ideal case, is that I would like to do this. And then like we have text, chord, probably, right? And I can do this. Okay, totally messed everything up. All right. So we can have stuff like that. And then colors, I can do this. So immediately we run into a problem that we can just take a function, right? So we would need, and actually need, to do this or something like that, and then take the pointer to that. I don't think there's any way of dealing with that, right? But I think immediately, like that's a way nicer API. Then I would need that like vertex count or anything like that. And there is something that also needs to be done for indices. And for that, I would like to, I mean, it could just work the same way, where it's like I snap off the vertex batch index or vertex count or something, and that's my base, and then I can do like vertex batch add index that will take local index plus the base, or maybe it could even be like internal to base. So I kind of just give it a local index, and it's like maybe this function would sort of say, okay, the indices that you will be passing started from this base, and then like a function can basically say, or actually it doesn't even need an ending function, because later it'll kind of come here and yeah, I guess, you know, since I'm imagining like an ideal API, it could be like vertex batch begin vertex set, let's say, and then here it will be like add local index, for example. And also you can see like I don't need this iteration anymore like that. Like this becomes pretty much probably more readable to just call this 6 times. But yes, something like that. Of course, there is stuff that's kind of like error prone in terms of us not knowing the type of things as we call this function, for example. And I think I will think of ways to improve that later. But I guess that's it for now. This is pretty much the ideal version of the API I would like for my drawing, which I think is a lot better. Of course, at the cost of everything being duplicated in RAM in my render unit, but, or I guess vertex batch. But I mean, I don't know. I don't think it's that significant. And of course, like even when using this, if you really need such a, you know, low level GL stuff, well, you can just call actual GL, right? Nothing stops you from just calling GL functions and having a custom vertex batch. And I would like to also have a version where you can sub, because actually I think this is pretty, it can go well with the existing stuff that I have, right? It's just that the existing stuff, well, I guess not really, because I'm saying in the existing way, there's no point actually copying the data, right, to another place in RAM. Like you just pass it off, right? But I don't know. Maybe it can just be a thing like here, for example, I do memory arena freeze and unfreeze, like maybe, so you can kind of see that unfreeze is related to the draw, so maybe I don't know, maybe like you can grab a piece of memory from vertex batch and it'll be, or maybe there will be an arena associated with each vertex batch or all vertex batches, something like that. So like this stuff becomes kind of more related to the vertex batch. And maybe even that means you don't have to actually call this sub stuff, but you like grab a piece of memory, populate it in here, and then when you draw this, it does everything automatically, right? So yeah, there are some ideas about how to improve this, but I think I'm out of time for now, and the plan is for me to come back tomorrow morning again and hit this code hard again. So yeah, this is it.